So the overview of the first unit is that introduction to machine learning, and the machine learning we talk about AI, ML and DL. So this is one thing we need to focus on, that what is, before we are getting into this machine learning, we need to understand what is the artificial intelligence, then what is machine learning, and what is deep learning. So we'll see that in the video. And then the most important, while getting into the machine learning, the types of machine learning we will be discussing. So one is the supervised machine learning, then the classification is into unsupervised and reinforcement learning. And a major concept in this machine learning we will discuss further, the curse of dimensionality. Then after that we will discuss the overfitting and underfitting conditions in machine learning, and along with the term called bias and variance. These are the important parameters, the key words that we studied in the machine learning, basically in supervised machine learning. Okay, so and after that we will be seeing what is a feature or feature vectors, and then what is data set, or what is training data set, what is testing data set, and what is called validation. Then further we go for k-fold cross validation for the supervised machine learning. Then the performance metrics like confusion matrix. This is focused on the syllabus, but we will be looking at the performance metrics of supervised separately and unsupervised separately. And for supervised we have linear regression and classifications. We'll see that also. And this ROZ is also a performance metric we used in the classifications. Okay, so this is all about the module 1 introduction, what we studied in module 1. So we'll get into the machine learning. So what is machine learning basically? So the machine learning, the term machine learning is coined by an early American leader in the field of computer gaming and artificial intelligence. The name is Arthur Samuel. He coined the word machine learning in 1959 while he was working at IBM. And he defined the machine learning as a field of study that gives computer the ability to learn without being explicitly programmed. So that is, we are not going to give any specific programming to learn from something. So the computer start learning itself without being programmed. So that's what the definition he given for machine learning. So another one definition is that machine learning is concerned with the question of how to construct computer program that automatically improve the experience. Okay, so what is machine learning then? So machine learning is a type of artificial intelligence. Basically it's a subset of artificial intelligence that allows computer to learn without being programmed. Okay, so it involves feeding the data into the algorithm, and that can identify the pattern within the data and make predictions on the new data that we supply. So it typically learn from the data sets, like the input data that we are providing, and then it will find out the patterns within the data. Now it can able to identify the pattern in the data. Now when we give a new data, then it can able to predict, go for some predictions on the new data, and this knowledge is attained from the patterns that it identified from the previous data. So where we use this machine learning, basically you can see that a number of applications are highlighted here. One is that speech and image recognition, one application is that, and traffic alert using Google Map, because we have huge data set, and using that we can go and predict it. Prediction is possible. Then online customer support, the chat box, which is the one of the major application that we seen in online marketing. Then Google translations, predictions, feature extractions. Then you can see self-driving cars, like you can able to predict where the positions of the car, what is the movement, so and so you can predict it. You recently see a video which the Tesla cars are identifying an accident is going to occur prior, like it can able to accident when an accident is going to happen. So these kind of capabilities are obtained with respect to the machine learning basically, and that leads to artificial intelligence. So these are the different. Email filtering is another one important application that we are using every day, where we can see in Gmail, where like the spam mails and non-spam mails, it automatically categorize, and all the spam mails will be moved to the spam folders, and you are not at all seeing those mails in your inbox. So that is also kind of machine learning. So these are the major applications, and this definition is basically given in the textbook, where a computer program is said to learn from experience, and this experience we indicated by a letter denoted by E, and concerning some task T, we are considering some task. So from this task it is learning, and that is called the experience. Okay, so and while doing this task, the performance measure is indicated by P. Okay, so basically we have the experience E, and this experience is obtained by doing some set of task, and that task is indicated by T, and the performance while doing this task is measured by a quantity, that the performance quantity is indicated by P. So if the performance at the task T as measured by P improves with the experience, so when you are keep on doing the task consecutively, then the experience is increasing. Once the experience is increasing, automatically the performance start increasing. So it's inversely proportional, like your performance start increasing while your experience is also increasing. So that is performed on particular set of tasks. Okay, so this is a definition that is given. So because you are getting trained on something, keep on doing the same, and now you can able to predict the result, accurate result in the future. So that's what the overall meaning of this particular definition for machine learning. So here we have given two different applications. The first one is like the handwritten recognition using the learning problem, the handwritten recognition problem. So recognizing and classifying handwritten words within an image, that is the task you are going to do. You are going to recognize where a few words, images are there, where you have written some words over there, so you are going to recognize it. That's a task you are going to do, and the performance of this particular task is nothing but the percentage of word predicted or classified correctly, that is the performance. And what is the experience here? The experience is a set of data set of handwritten data, the words, handwritten words, we have a set of data with given classifications, that is the experience. Okay, so likewise, so how much data set you are getting with properly labeled, you are experiencing it. While you are experiencing more and more data sets, such that your prediction capability keep on increasing, so the P goes increasing. Okay, so if you see the second example, a robot driving learning problem. Okay, so driving on the highway using vision sensors, that was the task. Okay, so the performance, the average distance, trace before an error happens. Okay, so the how much distance you are going to predict an error, that is the performance. So in order to attain that performance, you have this training experience. That means a sequence of data, that is steering commands recorded while human is making error. So this sequence of data that it's already learned, and using that knowledge, it can able to predict when a new error is going to happen, so that it can tell or take necessary actions. That is the performance. Okay, so now once we know what is this definition for machine learning, now we are getting into the machine learning process. So what is basically machine learning process? So in order to explain this machine learning process, there are 5 major steps in machine learning process. So as you can see in the picture, so we have the first steps in the machine learning process is data acquisition and understanding. So data is the fuel, so you need to gather the data, and that is the first step, and understand what the data is. So that's the first step. We'll explain this one by one. So the first one is the data acquisition, the second one is data cleaning, and inside this data cleaning we have two sub sessions are there. Your feature extraction is there and feature selection is there. Then the next one is the modeling, where the test data, train data, you are splitting the data into test data and split training data, and then your model testing phase. So it's completely in the modeling, then your deployment. Okay, so we'll see one by one. So this is the 5 steps, like data acquisition, then data cleaning, then data modeling, then model testing, and then deployment of the final application. So what is data acquisition? So the first step in the machine learning process is to get the data. So we need data. Okay, so from there we started. So once you get it, for any application or for any field we want to apply machine learning, first we will gather the data from the scenario. So this will depends upon the data, is basically depends upon the type of data you are gathering and the source of the data. So from where you are going to achieve, you are going to collect the data from the sensor, or you are going to collect the data from some some servers or whatever the scenario is. So from where you are going to collect the data and what is the type of the data. So this basically matters. So this can be either static data from an existing data set, database, or it could be a real-time data from an IoT system. So you have different sensors. So what is the static and dynamic data means? Static data is segregated on a particular place and it is fixed there, and it is like there is no changes on the data. A large quantity of data is staying there in some memory. So when we talk about the real-time data, from, if for example you have IoT sensors and all, well, real-time data set means current second by second, or based on the time period, each bit of time it is going to save some data into the data set, the storage. So your data is continuously updated over the time. So that is a real-time. It's keep on generating and saving into the particular storage. So that is called real-time data. And we have some pre-existing data, we call it as static data. Okay, there is no change on the data. So the data is, we'll see what is the data. Data is some different types of information basically, and usually formatted in particular order or a manner. Okay, that is called a data. Then what is information? So information is defined as a classified, organized data that has some meaningful value, that is called information. So information is that it's basically data but has some meaningful value. Okay, so that is called information. So this is the first step. Now the second step is your data cleaning. So data cleaning, in a sense, the raw data that you have may have unfilled data, blank spaces are there, duplications are there, errors are there. So many things, missing elements are there. So many problems are happening inside the data. So you need to clean up. If there is any duplication, you need to avoid the duplication. If there is some missing data is there, you need to avoid those fields. If there is blank spaces are there, you need to avoid that spaces. If there is unknown format data are there, then you need to avoid those data. So you need to clean all these and you need to make the data ready for your processing. That is called a data cleaning process. Okay, once you've done your all this process, cleaning process, now the data goes to the next phase. So basically the data we loaded in for the machine learning are in the format like either it's a CSV file, a kind of Excel format, that is CSV file, comma separated values. So then we have XML format. Your data set is in XML format, and sometimes we load the data set in JSON format. So these are the basic format of data we use to load into the machine learning. Which kind of application we are using, we usually get the data sets in these formats. Okay, so finally when the data set is cleaned and we loaded into the the modeling, where we will split the data into two sessions. One is your training session and one is for testing session. So most probably we will be taking 80-20 ratio. So that means 80% of the data set is used for training and 20% of the data set is used for testing purpose. Sometimes we go with 70-30 also. Like it's user defined. The one who is writing the code, they will define how much the ratio they are going to keep it, like how much percentage of data is used for the training and how much percentage of data is used for the testing. So that is defined. So this step is like, then the amount of data you use for training, we apply the machine learning algorithms. So the machine learning algorithm is classified like binary classification, then regression coming into your supervised learning, your binary, your classification comes into picture, your regression comes into picture. So for training you need to select some model, so you pick up some algorithm and apply this data set into that particular algorithm. Then this either it do the classification algorithm or it can start learning using the regression. So then it start learning on the training data. Okay, so once the training data is done, training on the data is done, and they will identify the pattern within the data. Now we need to see the score of like how the prediction capability of that particular model. So for that we need to load the unseen data, the balance 20% of data we loaded into the system where the machine learning model. Then now it start predicting based on the learning that it attains from the 80% data. Now it is going to apply the knowledge into the 20% unknown data. So that is the testing phase, and once the testing is done and you are getting very good accuracy and all, then you can go for the production phase. You will deploy this machine learning model into as a real application. Suppose your accuracy is not up to the mark, then you can go for hyperparameter tuning. You need to tweak some of the parameters and you can improve the accuracy of the prediction, and then you can again come back to the deployment phase. So these are the different types of the complete machine learning process. Hope you enjoy this video. Keep listening to this course, and we will be posting the video based on the syllabus every day. So we'll see again in the next video. Thanks for watching.